Hi, thank you for the nice introduction, and thank you everybody for being here at this webinar. Okay, well, I don't need to present myself because it has already been done. Let me just share the screen and start the presentation. Okay, so today I will speak about how we are using the cloud and the SWIRRL API to work with the virtual research environment within the EPOS. And but the idea is to let's say not to enter into the details of Earth science, of the Earth science domain, while instead to focus on the infrastructure and the IT system involved in this, because we understand that probably the audience will be outside the Earth science domain. If you are interested in some specific Earth science point, we can discuss during the QA. You saw my presentation. I'm not I don't have a background in solid Earth science, so I can answer partially your question on this topic. Or I can bring your question to more expert people. So the outline for the webinar is the following. So I will start with a brief introduction to what is EPOS and on the EPOS platform. And then I will pass to the topic, the main topic of today, so the distributed environment. And for those, I will describe the architecture, the infrastructure, the API we are using, and the software that runs the background work. A couple of words regarding how we are bringing these topics from EPOS to EMVRE and from EMVRE to EOSC. And then I will present you a demo. It will not be a live demo, it will be a recorded demo, but if you have a further question, I can show you live the answer if possible. Okay, so let's start. EPOS stands for European Plate Observing System. It has been established as an ERIC, and I will show you in a moment the timeline for this. And the aim and the mission is to be the only European research infrastructure dedicated to solid Earth science. The ERIC started with a clear focus on open science and implementing FAIR principle. And this is the reason behind some or many or even all the development decision and the architectural decision behind our platform. You see here the numbers of EPOS, just to say that it's not a small thing, it's a huge community effort, and the production system we have in place is widely used. As I mentioned, this is the timeline. So the story started in 1997, and the platform became operational in 2023 or 24. So this is the project that brought the platform to the operational phase. And once again, the main point is the focus on the FAIR principle and the open access. And this is why we are collaborating with a lot of different other institutions all around the world. We are now strengthening our partnership with the US, Australia, and also New Zealand. Is probably not present in this slide, but we are working together with them. But in particular, our main area of focus is Europe, and I want to cite here especially the EMVRE community, where we are collaborating to create an EOSC node. and EGI, that is the e-infrastructure that allows many of our goals and target, providing infrastructural support for them. And today we'll see how they support the distributed environment. Let's move on the EPOS platform, and what's important here is not the intrinsic details per se, is the fact that the same paradigm can, and it is already applied in different fields. So maybe this can be interesting also for your field if it is different from solid earth science or the environmental domain. So the main structure is the following. Data are produced, stored, and maintained near the source. So we in the EPOS ERIC, we are hosting the platform, but we are not storing the data. The data remains under the responsibility of national research infrastructures and distributed data centers. They build web services to access those data, and our work together with the community is because we have 10, or nowadays they are becoming 11 thematic communities in the solid earth science, so volcanoes, satellite, seismology, and all the others. So our work is to discuss with them and to find out the best and more useful and more sustainable let's say standards for exposing the services and describing the services, because our platform is metadata driven, and this is how we ensure the interoperability as well as findability, accessibility, and reusability of the data coming from the different sources. So we use a DCAT extension. It's called EPOS DCAT application profile to describe not the, also the dataset, but mainly the services that are used to access the data with all the possible parameters. So there is a description of how user has to provide, I don't know, spatial or time data, time boundaries to access the data. And you will see this in action in the portal. It's much more easier to see it in the platform. So we work at this integrated core services in the interoperability layer in order to offer to the user access, visualization, download of data without caring about the different and the huge, and I can assure there is a huge variety of data models, different web services, different formats, and whatever. We are taking care of this, and the user will access the data seamlessly. This is a snapshot of the platform. I will go into the details during the demo. And we are now counting thousands of visitors from a lot of countries all around the world, in all the countries. And almost all the services are open access. There are just some of them that requires authentication, because they provide sensible data, but we published a data policy, a new data policy recently, specifying exactly the terms of embargoed or restricted access to data. These are some of the studies that can be done within the platform. I cannot enter into too many details of the science behind those, but you can see that there are different disciplines involved, from earthquakes to tsunami, surface displacement, anthropogenic hazard. Okay, we missed volcanoes here, but we have also volcanoes. And scientists are using actively the platform. If you went to the EGU, for example, this year, you have probably seen some presentation involving studies done with the platform. But accessing the platform and the data from the platform is not always enough. And that's why we are starting developing the so-called ICSD, so the distributed part of the platform. The idea is that data needs to be analyzed or visualized in very specific and computing intensive environments that cannot be hosted within the central platform. So here is a scheme, or a high-level scheme of the architecture. So we have the data coming from the thematic core services arriving at the ICS, so ICSC, so the central platform that has its own hosting and its own software. And this platform is connected to external distributed nodes that can offer more computing resources and specific software to work with the data. And once again, our work is to allow users to interact with the data, even in the distributed environments, without caring too much on how the data arrive there. So the idea is that people select data and they get them without all the steps that are done behind the scene by the platform. This is an example, and this is the example I will show you later on. So from the platform, we spawn a distributed environment with a Jupyter notebook that already has in its file system the data that the user selected from the platform, and the user can do all the visualization, all the analysis needed. Jupyter notebooks are not the only distributed environment. We have also a visualization platform called Enlighten, but today we will focus on the Jupyter notebook example. How we can provide this with the three main ingredients. The first one is the infrastructure, and for the infrastructure we rely on EGI. Okay, it's not exactly today, it will be in I think 5 or 6 days, but we are celebrating 1 year of the Memorandum of Understanding we signed together with EGI, and from that moment we started providing this distributed environment using the EGI infrastructure. This is not the only collaboration we have with the EGI. We are working together in the Embry Hub Next project that I will show you later on. And during this year, we have worked together also to many, I'll say at least 4 or 5 new proposals for new European projects. One of them will start in September. It's called the EOSC Mesh, and as the name says, it works toward EOSC, and more precisely, in that project, we will collaborate in establishing the Embry node together with the AGI node, because also AGI will have its own EOSC node. So we are celebrating 1 year. We have done already a lot of things together, and more will come. You can look at these references once you get the slide of the webinar, or just to look at on a search engine. Then the second ingredient is this library of APIs developed by the KNMI. It's from the Netherlands, and we worked with the team there for several years before releasing this in the production environment of the EPOS platform. And we found this library very, very promising because first of all, it works, and it works very, very well in creating behind the scenes the workflow required to extract the data from the sources in the platform and send them to the Jupyter environment that is created and spawned in real time, more or less, when the user requires it. And the data are, as I said before, are directly sent to that environment. Moreover, and the platform provides snapshots and let's say provenance tools in order to certify all the steps that have been all the analytical steps and computational steps done on the data, so that the results at the end can be reproduced, can be validated, can be published in scientific papers, because there is a very precise and documented history behind them. And these two things, together with the fact that the APIs work in cloud environment with Kubernetes and Docker, so they are at the state of the art of the current technology. This is why we decided to go in this direction and to work with them. We have a very good relationship with them, and now we have this platform in place, this API in place within our platform. Just to mention, since we like and we believe in working with standards, the workflows that run behind the scene are encoded with the CWL language. That is one of the most prominent standards in the field. The third ingredient is our software, and the fact that the software is open source. So as I was mentioning at the beginning, today I'm presenting the EPOS platform and some application in the solid earth science domain, but everything you see can be applied in other fields, mainly because all the codes are open source. The EPOS platform open source is already being used in different projects or in different ERICs, different initiatives, like the one cited here. And I will show you in a moment the EmbryHub next edition of the EPOS open source platform. At this link, you can find all the documentation. It's very easy to be downloaded and launched even on your local computer. So although the platform is built to run on a cloud environment, you can run it locally on your computer to test or to, if you need to have your own map-based interface for your data, you can run it on your computer. And then if you want to offer it to your audience, you can deploy it on the cloud and share it and use it. So, okay, maybe you are not yet familiar with the platform, but this screenshot is pretty much similar to the one I showed you before related to the platform, but indeed it's different in the content, let's say. So the box is the same, the content is different, and the content we have here is the content coming from the Embry community and from the EmbryHub Next project. Instead of focusing on solid earth science, here we are focusing on essential climate variable, coming from all the possible environmental sciences. So for example, here, in this screenshot, we have sea level, platform, stations, displacement, but we have oxygen distribution in the ocean, in the atmosphere, and many other parameters, and more to come. So the EMRI project will finish next January, and by the end of the project, we are planning to deploy at least 20 or 25 essential variables. And this is done using the same approach of the EPOS platform. So even here, data remains at the source. We are collecting services, and this is why this element of the hub is called the catalog of services. The hub has other features, a knowledge base, an analytical framework, VREs, a catalog of data, and altogether we are offering services for the environmental science. Within this project, we are also experimenting a different way of handling the transfer of data to the virtual research environment, but it's still an experiment. Today I will show you the production code, the production platform with the SWIRRL API. We are not finished here, so we moved from EPOS to EMRI, and now we are trying to moving from EMRI to EOSC. The EMRI hub has been enrolled in the second wave of EOSC nodes, and starting from September, we will do all the technical and governance step in order to become effectively an EOS node. The catalog of services, and so the EPOS open source platform, will be listed among the catalogs of the of EOSC, and it will serve as a federated capability for thematic nodes like the EMRI node. Now, let's stop talking and let's start looking at things. Okay, no, I won't stop talking really, but let's start the video. I recorded it so that we will avoid live problems, but after the videos I have two. Part one is on the EPOS platform, and part two is on the distributed environments. I can show you on the real platform whatever you want, or you can try directly. You go on the EPOS website and you access the EPOS platform. Now let's start the video. Please interrupt me if you don't see it correctly. And okay, so this is the platform. You have to agree on term and condition, of course, and then you arrive on a map. And okay, if you are a little bit puzzled by the map, you have a search box for places. I go to the Santorini island in Greece because I can show you some interesting studies here. Now, you see that we have a lot of data and services, but if we want to shrink the number, we can create a bounding box, and only the services having data or within that bounding box will be highlighted. There is a free text search for refining furthermore the list, and you can click on the eye to see all the information available for all the services. These information are the one described in the EPOS DKTP profile. So these are metadata that we store within our platform. We have also very easy how to cite copy and paste features. The fair assessment is something I will show you later. And now, if you select one of these cards, you will see data coming from the service. In this case, we have this kind of beach balls that are moment tensor data for earthquakes. And we have a lot of them here, so we can further refine the parameter of the service. For example, asking for only the earthquakes having magnitude greater than 3. And we discovered that most of those earthquakes have a magnitude bigger than 3. We can check this also in the table. Now I enlarge the visibility of the table, and we can, for example, order the table showing with increasing magnitude value the earthquakes that have been collected. You can download the data on the table reflecting the filters that you have applied. Now, we can also show multiple layers on the map, but in order to fix a layer and add another one over it, you have to click on the star. And once you click on the star, you add the service on the favorites, and you can build another one on top of this. So these are the European fault source model. And if you're wondering what are these lines, you can open the legend and discover that, okay, these are lines for normal, reverse, right lateral, or left lateral fault of the earthquake. You can play around with the legend. You can customize some elements. And the interesting fact is that, okay, we run the analysis here around Santorini, but considering the favorites you have stored, you can move around on the map, select a different area, and have the data for this specific area with the same parameter you have stored before. So now we see only the beach balls and not the faults, because I forgot to click the star on the fault. Now, adding the star there, we have also this information. There are other filters, for example, time filters, data providers, or you can filter them by country, for example, let's say Italy. And you can select one or more of them, and you will see the services filtered depending on this. We have also a different data visualization. I've already shown you the map and the table. And there is also the graph, but for the graph, I will prefer to go to load one of our scientific examples. So these are real scientific let's say, studies done on the EPOS platform. And for example, let's go back to Santorini. Here we have the list of services. You will receive a warning, a confirmation warning, because loading a scientific example, all your favorites will be replaced by the favorites of the example. And here you can see the graph included in this study. So it's a time series of earthquakes. And you see all the elements near Santorini regarding this study. So not only the beach balls, but other elements. And this helps us in showing another feature. So let's say that we don't like the circles, we want the stars. And now I want to pass this study to one colleague. What I can do is to click on the share button in the top right part of the screen. And this will create a static URL that will always show the platform with all the configuration you have now on the screen. So you can pass this URL to a colleague, you can put it in a paper, wherever you want, and this URL will always return the map with the parameters and the services you have selected. Now, the map, the platform does not have only data. So let's try to navigate the other tabs. So we have the facilities. At the moment, we have laboratories, equipment, and stations. And for example, let's try to view on the map the volcano observation laboratories. So at the moment, we have only these three. So the map automatically moves there, so in the zoom in the correct position. But if you want more things, you can go for GNSS stations, and you will see how many of them we have. So GNSS, so geodesy is a much more represented field, at least in the facility place. You might notice some delays, but this is because we are not storing the data. So we are asking the GNSS web service, and we are retrieving the data, and this requires time. Now, if we reduce to Greece as a country, you have only the Greek ones. You can click on each of them and have all the information. These are coming from the metadata, as I was telling you before. So moving on, apart from facilities, we have also software. And this brings us to the next part of the demo. Here you can see that we have a list of the of Jupyter notebooks. You can download the Jupyter notebooks if you want to use them locally, but the best thing you can do is what I will show you in the second part of the demo. So I believe this video ends in a moment, or maybe I forgot something. Oh yes, I wanted to show you what we have in the menu. Okay, feedback and other things. The important part is the EPOS API, because also the graphical user interface relies on our own APIs, and you can use directly the APIs if you want. And this is the FAIR assessment, so where we collect the findability, accessibility, interoperability, and reusability scores for all our services. It's a FAIR assessment of the services, not of the databases. And this is why we developed our own FAIR assessment. It's called the EPOS FAIR assessment. And you can read all the details regarding this assessment in the dedicated page. And now the video ends for real. So let me close it, and let's move it to the next slide with the video regarding the SWIRRL APIs in action. Okay, maybe here I need to stop it sometime. So first of all, for accessing this feature, you have to open the Analysis tab, as maybe you saw it very quickly. And the Analysis tab requires a login because we want to allow all users to have to use it, and we don't want users to occupy all the resources available, although AGI provides us enough resources. So in order to check for this, we require a login, and we limit the users only to have 2 environments at any time. The login can be done in different ways. This is another AGI tool we are using, because, okay, we are using Google for our internal email system, so we can log in with Google, but we can use also the AGI check-in or other sign-in mechanisms. So if you have an account in any of these sources, then you can log in with that, or you can create a new account with the sign up you have in the top right corner. Now I go with Google, and once I log in, in the Analysis tab, I see the environment I have already created. So this is ready for the webinar, but I will show you how to create a new one. So you just have to give it a name. So second environment, a description. Okay, this is to show how to create an environment. And environment type. So here we have 2 types, Jupyter Notebooks and Untitled Web. The Untitled Web is the visualization platform I mentioned before, but now we go with Jupyter. And with Jupyter, you have two options, and I recommend you to use the EGI one. The CipherNet is the one we used while developing the feature. It's still working, but on EGI we have more resources. Now, the environment is still not ready because we haven't launched it yet, and moreover, it is empty at the moment. So let's see how we can add a Jupyter notebook to it. So now there is this blue button. It wasn't there before when you have the analysis tab closed. And just clicking on it, you can add the notebook to the environment. At the same, in the same way, you can select one service. I picked one randomly. You have the blue download button. You see what you can bring to your notebook. So in this case, I chose the GeoJSON and I select the environment where I want to bring the information. And now I can run this environment. The environment is spawning in real time, so it requires some time. That's why I have already the EGI webinar ready one, but at the end of the video, I'll show you that in just a few minutes, the environment is ready. So this is the Jupyter environment. You might be familiar with it. And this is the Jupyter notebook I'm going to use. It's a Jupyter notebook created for a summer school last year, and we are still using it. And once again, it's working on Santorini, and that's why I showed you the Santorini map before. And now, like in any Jupyter notebook, you run all the steps. So, okay, there are a couple of import and updating steps. And then here you create your own bounding box around Santorini. And okay, in the following step, you will see that a map is created. Okay, now I recreated it because I've already run the notebook before. So this is a base map with some information of the main rocks in Santorini and the nearby regions. Then, okay, we have some geological map. Okay, it's not printed here, but I can show you in the live later because, yeah, these two steps were skipped. So, okay, you can compute the balloons for the earthquakes in this study. You can compute graphs on cumulative seismic moment. You can have data coming from GNSS stations. So if you are a solid Earth scientist, you probably know much more than me regarding what is going on here. And also, if you are skilled with Python, you can recognize all the commands. But basically, the important thing is that we retrieved the notebook from the platform. And in this specific notebook, we didn't use data directly taken from the platform. We are using directly the URL of the services. But in the other case, I'll show you in a moment. So the one that I created while I recorded the video, you will see that the data have been downloaded, and then you have there to analyze whatever you want to do. All the notebooks are editable, so you can add your own code here at the end. And the interesting features of the environment created by the SWIRRL APIs are the one that I'm showing in a moment. So here you have a sort of a quick recap of the features and a quick how to do things. Well, it's relatively easy. So you have to click on this tab. And if you log in to your GitHub account, you can then create and store their snapshot of your computation. So then you can roll back previous steps, but anyway, all the steps that modify the environment are stored in this provenance tool, where all the records, all the timestamps on the logs are stored. And this is how you can prove your work. And okay, this is the other environment that is ready. So I launch it, and you will see here that this environment does not only have the notebook, but if you go on the data tab and you go to the latest, you have the GeoJSON file we have selected before. So, okay, opening it is not very useful because it's a very, let's say, not for human, it's not human readable, but although you can, but it's for analysis and computation. And that's basically it. So you saw how easy is it to create an analytic environment populated with data coming from the platform, and no, I don't want to see it again, and to do your work. And this can be done in the solid earth science domain. It will be possible in the Embry Hub quite soon. We are working on this part of the features right now, and we plan to have them by autumn, let's say. And then if you want to replicate this on your own, you have all the software and the libraries to do that, because they are open source, also the SWIRRL APIs. If you need infrastructure, you have to knock the door at EGI or somebody else. But we are relying on them for this, and we are very happy on what we have. And that's it. I thank you for watching this. If you want to reach out to me, this is my email. And now, if you have a live question, we can try to answer them live.
Thank you so much. Thank you. That's a very, very nice talk. We already have a question in the Q&A box from Fernando. Actually, he asked whether there are any, if you can read this question, although from the focus of EPOS is Europe, but does it provide information service from Brazil? Any collaboration with Brazil Institute? So I can.
Okay, so the quickest, are you still seeing my screen?
Yeah. Yes.
Okay, so the easiest way to, and are you seeing, no, you are seeing the presentation, right?
We are seeing the presentation at the moment.
Yeah, so let me understand how I can show a different tab. Probably I have to stop the sharing and start again with a different tab. Here we are. So let me answer the first part of the question by looking at the platform. So if I go here on data and service provider and I select Brazil. Oh, my computer is very slow. Sorry for that, because it's too hot. Okay, Brazil. Here we see that we have some data or service provider from Brazil. And if I apply this filter, I can see where they are. Okay, they are all in the tsunami. So probably this map already also has some data from Brazil, and this is why it is listed there. Anyway, yes, we have plans to expand our partnership. One of the projects we have, European project we have submitted last June, is exactly on the international partnerships. But even without that project, we are very happy to collaborate with the new countries. So you can write me an email and I can put you in contact with the right people to start possible collaboration with Brazil. So it's the collaboration are all usually ended in with the three elements. One element is the source, so you in this case, EPOS ERIC, us, and the third part is the thematic core services. So depending on the kind of solid earth science domain you are working in, we can involve in the discussion the right thematic community, so seismology, GNS, satellite, or whatever. And if you provide more, we can connect you with more.
Thank you. Fernando, I hope it answered your question. Okay, and then we have another question from Flavio, and he asks, in case of sensitive data, is there any restriction, for example, site on the analytics runs when how you can handle this any sensitive data related?
Okay, so I can give you, okay, I see Valerio typing because Valerio is my colleague on the technical side, but I can try to answer also for other people. So I really suppose that the same restriction we apply in the graphical user interface are applied in the distributed environment, meaning that if the source requires login, either you are logged in or you cannot access that resource. So and this is true both if you try to download the resource directly from the platform, or if you put some code requesting for the resource in GitLab. If the provider of those data put a security layer over the source, you have to interact with that.
Also, Valerio also provided some answer. I hope that answer your question, Flavio, and very good question. Thank you for all this discussion. Any other question from our audience? Is very unique opportunity you can discuss directly with our expert. Yeah, this is a very, very nice work. Excellent. And also you are kind of a pioneer in using this EOS node. Yeah. Any
We
actually
are working on that. It's
okay. So what's the
it's
challenge?
not already there, but we are working with that idea in mind. Yeah.
Okay. So, okay, and I do not see more question from our audience, and then I would maybe I close this session with thanks to our speaker, Alexander, also expert from EPOS Valerio. Thank you. Excellent talk. Also, I would like in future invite you back for your new update of the work. And I thank to our all participant. I hope this bring you a valuable insight into your work. Thank you to be with us today. Also, I thank to my colleague Federico work behind the scene to ensure everything works smoothly. With this, I'd like to close our today's webinar, and thank you, Alexander, again, and
Thank you, and thank all,
hope
to
to
all
see
the people
you.
attending.
Yes, see you in Ghent in person. Yeah.
I'll be there. Yes.
Thank you. Bye bye. Thank you. Thank you, Valerio.